Good day, sir. We are Group 10. Today we would like to present about Smart Parcel Box. Before I start my presentations, I would like to introduce myself and my group members. My name is Lai Sini and my group members consist of Lai Kawai, Tai Shening, and Pei Hongbo. Now I would like to explain about the background of Smart Parcel Box. Smart Parcel Box was introduced to address issues in courier services. It is a prime concept of collecting parcel without physical contact. And they come with two forms. There is Smart Parcel Local, which is centralized, and Doorstep Smart Parcel Box, which is distributed. However, there are a few steps they need to follow when using the Smart Parcel Box. That is, deliver the parcel to specified local, and then it will notify the users once the parcel arrives. And then finally, the user can pick up their parcel. After that, I would like to introduce the Internet of Things, that is IoT. IoT allows machine-to-machine interaction by connecting things to the Internet. After that, it is able to operate automatically without human intervention, since the machine is integrated with computing capability. IoT is applied to alert parcel delivery, unload the box when delivery man deposits parcel, trigger and alarms for illegal delivery attempts. In addition, cloud computing is also important within this project. Cloud computing is actually a computing resource can be distributed with minimal effort easily. IoT and Smart Parcel Box system are able to balance the vast resources used. The functions created in the cloud is able to solve their limitations in terms of storage, processing, backup, and recovery. Moreover, Smart Parcel Box is come with several advantages. That is, users are allowed to collect parcels anytime, and then we can avoid the waste of resources due to unattended delivery from courier service. Besides, Smart Parcel Box provided various authentication ways for parcel collection. That is, passcode, face recognition, fingerprint, account authorization form application. Other than that, cloud-based video surveillance is provided for advanced safety and security. Besides, Smart Parcel Box is built with extra durable materials to defend against outdoor elements. After that, back-end cloud system is used to monitor all parcel deliveries and pickups. In conclusion, Smart Parcel Box can be concluded into 3S, that is Smart, which is able to monitor and control through the web application, Simple, which is never miss deliveries, and the last one is Secure, which provides 24/7 protections against thief and vandal. Now I would like to talk about the future trend of Smart Parcel Box. According to Fortune Business Insights analysis, value of Smart Parcel Box system market will increase from 780 million to 1,630.2 million. The pandemic increased the daily parcel delivery rapidly and the demand for an intelligent system for managing the delivery parcel. In terms of development, future Smart Parcel Box is expected to equip with cooling function to deliver temperature-sensitive items such as groceries. This is supported by the statistic by digitally involved food shoppers, which show over a quarter of the US populations purchase groceries online.
Thank you, Xingyi. I am Shanyi. We're going to present the comparison between the cloud services that provide technologies in the Internet of Things IoT, which supports the functionality of Smart Parcel Boxes. The cloud services that form part of this comparison include Amazon Web Services, AWS, Microsoft Azure, Alibaba Cloud, and Google Cloud Platform GCP. From the perspective of services for IoT, AWS offers a complete series of services for IoT such as AWS IoT Core, AWS Greengrass, AWS IoT Device Management, AWS Device Defender, and AWS IoT Analytics, and etc. Microsoft Azure supports IoT with the Azure IoT Central and the Azure IoT Hub, and also Azure Digital Twins. While Alibaba supports unique certificate per device, scene orchestration, part or sub, protocol bridge, device shadow, and so on. In Google Cloud, it provides device manager protocol bridge such as BigQuery and Data Studio to perform processing and analysis on the collected on IoT data. From this slide, the strength of AWS is to combine tools, administration, analytics, and security with wide array of resources. Microsoft Azure provides partnership with Oracle, VMware, Microsoft, and so on, while Google Cloud offers an end-to-end AI platform. Besides, Alibaba Cloud supports host large applications and sustain a big number of users at once. In contrast, the winners costly services characterize AWS as compared to others. Azure also has a lower availability zone ratio. Google Cloud does not attain the enterprise maturity level of other cloud platforms, while Alibaba Cloud has a much narrower adoption in global. Needless to say that it don't have the best cloud platform in terms of cost optimization, but it may provide the services, products, and costs that are suitable and fit the requirements of customers. Thank you. Let me pass to Kawai.
I'm not Howard. I'm going to talk about problem statement. As the outbreak of the COVID-19 pandemic, people were forced forced to stay at home due to a lockdown, which led to the drastic rise in online shopping volume. However, the traditional logistic method requires the delivery man to hand over the parcel to the buyer physically upon doorstep delivery, which is very risky for spreading the virus. Besides that, the general doorstep delivery requires the delivery man to take information such as IC of the person who picked up the parcel as proof of delivery. Even though this works as a guarantee for traceback if any undesirable incident happens, it still risks personal information leakage. Sometimes, people may go outside and leaving no one at home. This forms the case of a delivery not attended, which leads to low efficiency, as the delivery man will have to wait and then call the buyer to confirm if no one is able to pick up the item. Even though smart parcel locker was introduced, the user still require additional effort to visit the parcel locker for physical pickup. Moreover, it's mostly placed at a crowded center, and thus the console is being used by everyone, which could promote the transmission of the virus. Next, the project aims to develop an IoT parcel box product, which is connected and managed through the AWS Cloud Services platform. The parcel box comes with 2 doors, 1 camera, and 1 web scaler. Users can first register their online order in the system. Upon delivery, the delivery man may request to open the parcel box door by submitting a request through the system web app. At the same time, the camera will recognize the waybill to verify the parcel box owner and open the door. After placing the parcel, the camera will take a photo of the delivery man as well as measure and compare the total weight to verify if the parcel has been put into the box. Upon successful delivery, a notification will be sent to the user. The design above allows the delivery of parcels to be completely contactless, while ensuring security and authenticity throughout the process. It addressed the problem mentioned in the previous section, guarantees the safety of health and personal information, at the same time avoids the waste of resources and provides convenience for those who live alone. Besides that, the recorded data can be extracted to perform data analysis and to gain insight for business decisions. Most importantly, necessary information about the delivery process is recorded in the system, which allowing easy traceback for validation if an argument happens. This is our architecture diagram. The first component we use is connector. It handles the authentication part of the system. The second component is IoT core. It allows IoT devices to interact with the AWS services through MQTT framework. The third component is Lambda, which allows us to run codes without any server and in response to various triggering events. In our solution, trigger sources are HTTP requests, update on S3 buckets, and message forward from IoT rules were configured to expand other AWS services with custom logic or create our backend services such as updating RDS record and publish to SNS topic. The first component is S3. It is an object storage. We utilize the service to hold our website and store images collected by our key camera. The fifth component is RDS. It is a database that is easy to set up, operate, and scale. We will be using MySQL database for our proposed solution. The sixth component is recognition. We can further use the image stored in the S3 bucket to perform different kinds of analysis. We use it to perform test detection. The seventh component is API gateway, which is used for creating, publishing, maintaining, monitoring, and securing REST, HTTP, and WebSocket APIs at any scale. In our solution, RESTful APIs have used for our web application to access functions defined in Amazon Lambda to enable communication with other AWS components. The eighth component is SNS. It is a durable, secure, and fully managed publish subscribe messaging service. Email subscription is used in our solution. The ninth component is QuickSign. It is an interactive dashboard which is used to perform data analysis on the data stored in the RDS to support the business in our solution.
That's all for my parts. Thank you.
Thank you very much. Hi everyone, my name is Benno and I'm going to continue the presentations by demo the system. So the demo will basically be a use case basis. So for the details of the use case, you guys can actually refer to the report that has been submitted. It is under section 6, the system architecture. So without further ado, let's get started. So the first use case is to let user register their own parcel box. And upon successful registration, the Lambda function backend will actually subscribe the user to the parcel box topic so that if there's any update, the user can actually receive the notifications in future time. So this is the pre-registered account, so now just log in. And from here, we can see the option over here at parcel box just shows this. Then the ID is actually retrieved from the cognito because like when user log in, we get the ID and just pre-filled it. And then assume that we bought a new parcel box 01, and we submit our record. And here we can see updated successfully. So once updated successfully, over here, right, we can find this new record. So the parcel box is registered, and the SNS will actually have these notifications for us to confirm the subscription. After confirm, let's check from the SNS. Yeah, we can see the SNS subscription added. The second use case to demo is to let user register the online order that they have placed inside our system. So from here, we can see this record order option. We just choose this, and these are the details that we have to fill in, like phone numbers, the parcel box that we have just registered just now, and the order ID. So yeah, once submit, we can see order recorded successfully. So when we back, right, we can actually see this new order added over here. It is this one. Okay, and from the database here, we can actually see also a new order added in with the tracking number, and also the status has not received because it's not yet delivered, and then the DMID is now. Okay, so the next use case to demo is when the delivery man arrived at the doorstep and want to deliver the parcel. So these are the things that involved for this use case. First of all is these two IoT elements. One is the camera and the other one is the door, which is used as the IoT object, and both actually we have run the code and make it connected to the IoT core already. And over here, these are the topics, IoT topics that we are going to monitor throughout the process. And let's start by submitting our request. This is the user interface for the delivery man to submit their request to deliver the parcel. I have logged in my account, and let's submit the request. Okay, perfect. It says that order match. This basically means that the Lambda function backend has used these two elements to match with the database and found the same record to verify that yeah, this record actually is valid, and to post a message to the camera to capture the waybill for the further recognition. So from here, let's check out at the camera side. We can see that it had received this authorized message, and this one will be used later. So once the camera receives the authorized message, right, it will post the waybill image to this record image topic. So from here, we can see this record image receive this photo, and by IoT role, it is passed to this S3 bucket. Let's refresh. We can see the image is posted here, and it triggered the Lambda function to do the recognition, which we can check from this CloudWatch screen. Okay, so this screen we can see. Okay, this is the result that we retrieved from the recognition, and by matching the order ID with all the elements here, once a pair is matched, it will say that it is true that this waybill belongs to this parcel box, and it will post the message to the DM door permission topic to say that the door is allowed to be opened, and we can see from here success. So let's check out the DM door permission. Yes, authorized. So looking at the door, it will receive this authorized message, and by the JavaScript, it will actually post this door open status back to the IoT topic. So from here, we can see, yeah, the open message is received, and then we can see from here, right, this the order that we registered just now, the status has been updated to in progress, and the DMID has been updated as well. After the delivery man placed the parcel into the parcel box, at the moment that he closed the door, it will trigger a series of functions that we are going to demo next. So first of all, from here we can see 4 IoT elements that will be involved later. It includes the weight scaler, the camera, the alarm, and also the delivery man door. So at the moment that the delivery man actually closed the door, it will post this message up to the door status telling the system that the door is closed. Then it will trigger the 2 IoT elements over here, which includes the weight scaler and also the camera. So both of them will receive the status closed. We look into the camera first. When the camera actually receives the closed status, it will straight snap a photo of the delivery man. So this is work as a record of the delivery, and it will be posted to the topic deliver record. And by IoT rule, passing it to the S3 bucket, and to be recorded inside the RDS. So you can see from here, this is the photo that have been uploaded just now. And then it will be passed into this deliver parcel record here. So yeah, you can see from here, we have this delivery record over here. The elements that we take from the S3 bucket is actually the name of the picture, which is to record this picture belongs to this delivery attempt for this order ID. It will then update the user order status to complete. So we can see from here the order just now, the status has been updated to complete. Then the second half of the operation is actually for this weight scaler. So once the weight scaler actually receives this closed status message, right, it will then post the total weights of the parcel that are currently inside the parcel box to the IoT topic, which is under this scale. You can see parcel box ID, the weights, and also the door type. So once IoT topic get this message, right, it will trigger the Lambda function to do a comparisons. Like if the current weight is greater than the most recent weight record, it will then classify this as a success delivery attempt and post a success message to the SNS topic. So from here, we can actually see this SNS message topic over here saying that new parcel delivered to the parcel box 01 to notify the user. However, if the total weight is actually lesser or equals to the most recent captured record, it will then classify this delivery attempt as an error and notify the user through SNS topic at the same time to trigger the alarm that is attached at the parcel box itself. So let's try out by submitting lesser weight records. The one we submitted just now is actually 4. Now we post it with a 3 kilo. Let's see how it's going to happen. So I publish this message to the scale topic, and we can see that the scale actually received this, which is a 3. So it actually rings the alarm, and from the SMS over here, I can actually receive this warning message telling that something is missing inside the parcel box 01. So the next case is basically after the delivery man has delivered the order. When the user gets back to home, he or she would like to open the parcel box and take out the parcel. So what they need to do is just log in their account and submit this parcel box ID that they would like to open from this section. So once submit, it will have this parcel box open, please collect your parcel message. This basically means that the user has a registered parcel box in this system which match this ID, so the system allows he or she to open the box. So the Lambda function will publish an authorized message to the user door permission topic. You can see here about the authorized. Then the user door, we can see from here, yeah, it receives this authorized message. And upon authorization, the door will send this door status open message back to the IoT topic user door status. And that's how the door is being opened. And we can check from here, this is the record. We stated that the home ball, possible 01, which is where the system actually try to match the backend record to verify whether the user can open the door or not. So after the user take out all the parcels from the parcel box, they will just close the door, which trigger these functions over here to publish the door closed status message back to the IoT core. So we can see the user door status is now closed, whereby the weight scaler is actually subscribing to this topic, so it will be passed to the weight scaler to update the latest total weight because the user take out all the parcel. So from here we can see that assuming the user take out all the parcel, that we set the weight back to 0, and then this message is published to this scale sites. So the total weight is now updated to 0 for parcel box 01, which we can verify from here. Let's check this out. Yes, we can see from original 4 kg, it is now updated to 0. The last case to demo is the data analysis from the business owner of the Smart Parcel Box Systems view. So first, once we have entered this quick site, we can link it with our RDS database by connecting it to the data source. So our RDS is this My Parcel Box. The database name is Parcel Box System with username admin and password PCS So we validate the connections and we can create the data source. And for example, I take user order as the table. These are all the entities, and I just user order for the analysis. Then I just visualize it. Then from here, I can actually choose the various ways on how should I visualize. For example, I can choose on this DMID for the business to actually keep tracks on which who actually delivered the most, who delivered the less, and try to do some managements on HR, or they can do some checking on the parcel box status to see how many of them is received or how many of them is not received. Another analysis could be the market share analysis, because inside the database will actually mark down the location of each parcel box, so we can check out at which state how many parcel box is there, so that the company can take decisions on some promotions in different states. So that's all for the demo. Thank you for your time.
Thank you, Hombo, for the demo. I'm going to present the further improvements can be implemented in the future to make the Smart Parcel Box system better. Firstly, face recognition technology is an easier and safer method to authenticate identity. Furthermore, develop a mobile application and linking it with the online shopping platform for auto-updating parcel ID on a real-time basis is suggested. Thirdly, the cloud-based video recording also be considered a better solution to record down the people who have interactions with the Smart Parcel Box system. Besides that, the action recognition for stealing can be implemented to replace weight comparison to detect the stealing cases more accurately, as well as trigger an alarm and send messages to parcel box owner instantly. Lastly, AI recognition technology on parcel condition understanding can help users determine if the parcel is broken for further actions such as whether to accept the delivery. That's all for our Group 10 presentation for Smart Parcel Box. Thank you and have a nice day.